So I was wrong. In a previous video, I said this. These aren't numbers because Bash can't have nested arrays, and arrays are always going to be of like string type in Bash. It doesn't have like strong types when it comes to what's inside an array. And honestly, I totally believe that. I really thought that was the case. But then a user commented on my video and they said this, and I realized, before I responded, I wanted to just double check. Before I give you guys information, I like to really make sure I know what I'm talking about in the comments, especially because I have a chance. I'm not like talking to a camera. I have a chance to actually like stop, let me research this, let me figure out what's going on. And I tested it and it worked. I was very surprised. So I dug through the, Bash manual, the man page, and I found out that, oh yeah, not only is this like allowed, it's actually specifically called out in the manual. So I just totally missed it. So in this video, I'll show you some examples of what it is exactly, and then I will fix the code from a previous video. In a previous video, I wrote a pure Bash JSON serializer, and I'm so glad I did that. Even though it was tough, it was a tough project, it ended up showing me some things about Bash, because after that video, I was able to come out with another video where shell check taught me something that I legitimately just didn't know with Bash. And now it taught me something else, not shell check, but going through this JSON serializing project, I realized that, oh, I was just completely mistaken about arrays in Bash, and you can actually store integers in arrays in Bash. So yeah, we'll dive into that today. We'll fix some of the code and we'll push a new change to this. And yeah, so first things first, if you don't know what I'm talking about, you can make an array in Bash. There's a couple different ways you can make it. I can literally just say array equals foo bar baz. And there we go, we've created an array. You can say, let's print out the first element of the array, which is at spot 0. You do it like this and we get foo. Print out a 1, we get this. Print out like this, you get that. They're super straightforward. They're very easy to work with. You can also use this extended notation. I can explicitly say declare -a for indexed array. This is exactly the same. If you omit this, Bash will assume you're making an indexed array. The reason this is useful is because let's say I were to unset array. Now it's not set to anything. If I wanted to make an associative array, this is like a key value store, you can think of it. I could say, foo equals 1 bar equals 2. Yes, this is the syntax for making associative arrays in Bash. If I do this, it looks like it worked, but it really doesn't. It actually ends up making an indexed array under the hood. So what you want is you want to declare -A. So lowercase a for indexed arrays, capital A for associative arrays. Why am I talking about this? Because let's go ahead, let's just get rid of all this. Let's unset array, and let's say declare -A array 1, 2, foo, 4. So 1, 2, foo, 4. Obviously, it's a little bit weird, but that's totally valid. You can do this. Let's go ahead and printf. So we can use this notation with printf. I'm just going to put angle brackets around. There's nothing special about them. They're just to format the output. You'll see. So we can put a new line here, and then we can do the whole entire array. So this is the notation to print out the entire array. We're going to separate them by new lines with angle brackets around the elements of the array. So 1, 2, foo, 4. No trickery here. It's just a very simple array. But here's the thing, let's go ahead and unset that array, and let's go ahead and redeclare it, but this time we can give it -A and a -I. So A for array, I for integers. Now let's take a look at how it's stored. Look at this. See, as you can see, we have numbers here, 1, 2, 0, and 4. This failed to parse as a number, so we get a 0 there. Be aware of this. If you're new to Bash, this can totally be a problem. Definitely make sure to validate user input. This is super useful when you, the programmer, are in control of what you're doing here. So why is this useful? Well, let's unset that array. Make sure we're not working with anything else, okay? Let's make a new array here. Declare -A array, and we can say 0x00, 0x01, and 0xff. So it looks like hex, right? These look like hex values. If we print them out with this notation, we get the exact strings. These are just strings. We're storing these as strings. If we were to treat them as numbers later, they'll get turned into numbers, but we're just treating these like strings right now. There's nothing special about it. So let's go ahead and unset the array, redeclare the array, but let's throw the I in there for integer, and then reprint them, and look at this. See, Bash stores them internally as integers. This is totally fine. It works with indexed arrays. It also works with associative arrays. So definitely something to keep in mind. I'll even show you, if we were to do a man bash, we can look for, I think it's like elements of, I looked this up later because I had to remember what it was. Nope. All the members? I'm gonna find it. Members. Okay, let's see if this works. Can I just search for declare -cap A for associative arrays? Here we go. Look at this. Bash automatically creates an indexed array if any variable is assigned using this syntax. So like I said, if you don't give declare, it assumes it's an indexed array. You can also do it like this. And look at this, you use -cap A for the associative array. Attributes may be specified for an array variable using the declare and read-only built-ins. Each attribute applies to all members of an array. So that's what's going on here. We're specifying the integer attribute for the array variable, which means all members of the array will be treated like an integer. So that's what's going on here. So when I said that bash doesn't support it, not only does it support it, not only does it work, it's intended. It's in the manual. So I just completely, somehow I missed that. I don't know what was going on there. Sorry for lying to you guys. I totally, truly believe that. But as you can see, like, I totally make mistakes. If you're watching me and you're like, Dave, oh my God, you are just so perfect. You never make mistakes. Also, you're super beautiful and you're wonderful and you're the best. You're totally right about that last part, but I definitely can make some mistakes. So let's go ahead and fix the JSON var command now. If you haven't seen this video, definitely go check it out. It's a ton of fun and you can totally watch me at the end, kind of like lose my mind a little bit because it was a tough project. It came together, we pulled through, so I don't want to spoil the ending, but it's a ton of fun. It's a cool project, but we need to implement some features that are missing in it now. So here's the program here. I talked about potentially solving an issue by using shopped to set the shell options, and a bunch of you guys had comments saying like, you should be able to use shop, that's totally fine. If it runs its own program, then it's not gonna be a problem. This isn't intended to run as its own program. This is intended for someone to take all of this code and put it in their bash RC or source it in their bash RC so it runs out of their environment. I was testing it by running it as its own code, but that's not how its intended usage is. So that's why I stay away from that. But yeah, so let's take a look at this. You can run the JSON var command like this, and it will give you the usage message. If you run it with -a, it gives you all of the variables that are currently set. Now, these are currently set inside the script because I'm running it as an executable script, but you can see there's a whole bunch of stuff here. We can limit this. We can say -e to only show the exported variables. These are environment flags as JSON. So we could pipe this to like JQ, and we can get a nice little pretty print. And yeah, super simple. We also have some other options. I have to remember exactly what they are. It takes the name of the variables arguments as well. So you could say like, I put some test variables down here just for us to, of course, test with. We have test int. So that is actually an integer. It should just print an integer. We can also give it, let's say, test string. There we go. We can pipe that to JQ, and you can see that we get both of these out of it. So super cool, super useful. You can see that we format the numbers differently than the strings. We're going to have to give this treatment to arrays of integers. So to get started, let's go ahead and add them to the test cases here. Or not the test cases, sorry. I guess we call them test things. Just the examples inputs that we can use. So we can declare -ai, and we could say, let's go ahead and do this. Test indexed ints. So this will be an indexed array of integers. So we can say like 0, 1, 2, 0xf, foo, bar, baz. Those should all resolve to 0. Okay, simple enough. We can copy and paste this down here. We can change this to cap a. Then we can make a simple associative array. So instead of index, we'll change this to assoc. So test assoc ints. We can do foo equals 0, bar equals 1. Baz equals 0xff, and bat equals foo, which should resolve to 0. So simple enough, simple examples here. Let's go ahead and rerun this script with those two names. So if we run this with a -a, they should be at the bottom somewhere. Yeah, assoc ints and indexed ints. So we could run this, test indexed ints, and there we go. There's the two of them. And as you can see, look at them. They're being stored as strings, not numbers. They get turned into numbers by bash. That's great. We get the 000 like we expect, but we're formatting them like strings. We don't want to be doing that. So let's go ahead and just implement that change. So again, if you haven't watched the first video, you're probably going to be confused by this code, but there is this nice little thing. We have a JSON encode string. So this is our function to encode strings. That's super useful. We need to not call this if they're integers, because formatting an integer is super easy. We just print it, basically. We don't have to do any weird formatting. Bash is already storing it as a valid number. At least we're going to make that assumption about Bash, the language. So down here, we have this JV encode variable. This is what we care about. Because encode variable gets called with our variable name, and then we do some processing. We check, is it an indexed array? Is it an associative array? Is it a integer? And if it's anything else, it's probably a string. So the nice thing is we put the array checks above the integer checks. This is super cool because we will go into this branch if it's a indexed array. So once we're in here, we can check if the integer flag is then set, and we can format it differently based on that. So here are our attributes. We have to save this into a variable. So let's take this, let's say local JV adders. And if you're confused why all these variable names are terrible and why they're super ugly, definitely go check out the original video. We have to namespace all these variables because of the way we're doing these functions. It's a whole mess. I don't want to spoil that, but it's a mess. So we can do this, JV, I can type, adders. There we go. So we have this in a variable now. Now when we loop over all the elements of this array, instead of just encoding the string always, we should check member type. So we can do this very, very simply. If JV adders equal star I star. So we know that it has a lowercase a in it, but if it also has a lowercase I in it, then we know it's an integer. So if it's an integer, we want to do something. Else, we want to do this where we encode it as a string. And that's it. And that something we want to do is literally just this. We just want to print this to the screen. We don't need to do anything fancy at all. We can do this. Printf %d that JV value. I guess I say we're not doing something fancy. We are kind of formatting it like a number. And that's it. That's all we need to do. And the beautiful thing when we go down here to the associative array, take a look at this. We format the key here, and then we do the colon space, and then we format the value. Hello, let's just do this. Simple enough. Move that over, and there we go. It's the same exact thing. When we process the associative array, before we print the value, we're going to check. If it's an integer, we'll print it like an integer. If it's anything else, we print it like a string. So let's go ahead and rerun this now. That looks good. That looks beautiful. That looks so easy. What a simple fix. How easy was that? That's incredible. We can do a little bit more testing here. Obviously, we could run this whole thing through JQ, and we kind of take a look to see what else is going on here. Yeah, so we have a number here. I don't think there are any other arrays with integers by default. I mean, we created some, that's great. There are some integers here. As you can see them, they show up as white instead of green. And yeah, we just have this, and we just have this. And yeah, that looks fine. That's beautiful. I guess we can do a nice little shell check on it. We get a bunch of warnings for these. It doesn't like that these are here. So we get warnings. Oh, we get word splitting here. We actually do want word splitting there, so that makes sense. And this is want to escape a single quote. This is how it's done. I don't want to escape a single quote. I'm not trying to escape it. I'm actually trying to store as a literal single quote. So I think this is fine. So yeah, there we go. Super easy fix. Not really that difficult. If you take a look at the git diff, we store the attributes in an array so we can reference it later. We reference it later. If it's an integer, we print it like this. Else we print it like a string. If it's an integer, we print it like this. We could probably wrap this into a function if we wanted to be clean about it. We could say like, you know, JSON encode value where we pass the attribute and the data with it. We could do that for now. I think it's fine just to copy and paste this logic for these two simple cases. If it expands the future, I would say we should definitely break it out into its own little function. And yeah, just declare -AI. So yeah, look at that. Bash has got AI built into it. I'm joking. That's a dumb joke. So yeah, with all that set up, I guess we can just do a nice little git commit here. Let's say arrays can have integers in them. LOL, whoopsies. And I can put whatever I want in the commit message because it's my repo and I do whatever I want. So let's go ahead and git push that. And there we go. Now the code is live. You can feel free to go check out that code, look at the commit message and see exactly when I recorded this video. How fun is that? So yeah, that's all I got for you guys. Thank you so much for watching. It's a little bit of a short one. Obviously, I want to give a quick shout out to my patrons over at Patreon. Thank you for your continued support. I appreciate it. If you want your name at the end of one of my videos, go ahead and sign up for my Patreon. It starts at $5 USD a month. Oh no. Hold on. I gotta restart this. That is incredible. Hold on. I've gotten all sorts of messed up here. I was gonna say, I hope you guys enjoy these quick little videos so I can just kind of like dive into these small little bite-sized things. Let me know what you guys think of the length of this video. And I just didn't expect this to happen here. This is incredible. If you're new here, when you sign up for Patreon, they let you put the escape character in your name, which means you can put ANSI escape sequences on my terminal. And I don't do any filtering because I like to see what kind of weirdness you guys can come up with, like Jordan making their name colorful or whatever is happening here. It's incredible. That's hilarious. That's incredible. That's beautiful. I actually have to go look through the file now manually and see what you're doing to accomplish that because you guys are wild. I do want to make sure no one has their name taken off. If you ever see your name not showing up here, yell at me. Feel free to yell at me because if you're paying, you deserve to have your name at the end of this video. I love that people can mess with the script, but I don't want them messing with anyone else's name. I don't think it's happening here, but I got to just double check and make sure what's going on here is totally copacetic. But that is hilarious, dude. That is what an incredible treat to see that. All right, let's see. This is for the super fans at the end of the video who want to see this. I'm slowing down the script. I'm very curious to see what's happening here because I don't think it was until we got to the next tier where this user did something to their name, which is just incredible. I checked and it looks like ProxyX is next after this user, so we will make sure that no one's losing their name here. But yeah, dude, this is so funny. I think it's so funny you guys do this. It's always a treat when I see this. Incredible amount of hearts, your name over the hearts, and then this C is peak. So I don't even know. I don't know if the C's being pulled up there, but that is hilarious. Okay, I can't tell where the one user's message starts and the other one ends. So you guys let me know. I don't know why your hearts are going to the end like that. That's crazy. Maybe you are trying to clear to the end of the screen. It's so funny. Yeah. I mean, you guys have heard me talk about this. I don't want anyone's name not showing up. If you're paying me money, your name should be on here. But so far, it looks like everyone's name is showing up. You guys are just doing some crazy stuff here. So we are making art. This is wonderful. Thank you so much, guys. What a ridiculous community we have here. So yeah, that's all I got. Take care, everyone. See ya.